Okay, hello. Am I audible?
Yes.
Okay, then good morning, good afternoon. So welcome to the Gardener community meeting. I will just quickly share the agenda for today. So for today, we have two topics, one from Plamen Kokanov regarding shoot control plane migration and one from Raphael Vogel regarding Gardener versioning policy. So Plamen, are you ready?
Yep.
Then please take over.
Yeah, let me share my screen. Okay, so can everybody see it?
Yes.
Yeah. All right, so the shoot control plane migration, I'll present the quick Gardener enhancement proposal for it. So the idea and why we need to migrate the shoot control plane from one cluster to another is so currently we can do this manually, but it requires a lot of steps and a lot of preparation. So it would be really easy and good to be able to migrate this automatically by just switching flag to trigger it. So another reason to do that would be if a seed is no longer operational, then Gardener should automatically move the control plane to a working seat. This is something that we will be able to implement at a later step when we can define better how or when a seat is not operational. So the other goals of this proposal is that Gardener will only manage and migrate resources it creates, and will not care about state and resources created by the extensions, and this migration should be handled differently. So extensions independently save their state, and the state can be then it is saved somewhere centrally, and it can be transported to another seat. And the already existing shoot reconciliation controller is reused for the migration flow as much as possible, so that we don't have to write new logic. So yeah, as I said, currently the control plane of a shoot cluster can be migrated manually. It requires deep knowledge, and with the possibility of extensions to change, the procedure can change as well. So this can make it slow and it's prone to errors. So the automatic migration will help us greatly with disaster recovery, load balancing between seats. For instance, when a new seat is created, then some of the control planes of shoot clusters can be transported to it. Or region efficiency. This means that if shoot cluster located in the US is the control plane of shoot cluster located in the US is hosted in the EU, then it will be easily migrated to a new seat which we can create in the US region. So for the next parts of the proposal, the host seat, we'll refer to it the host seat as the seat that currently hosts the control plane of a shoot cluster, and the new seat is the seat that we must migrate the control plane to. The resources and controller state, which has to be migrated between seats currently, are a couple of secrets which we cannot regenerate. They must be copied over to the new control plane. These are the certificate authority for the Cube API server, the front proxy, static token, and so on. And other certificates that we use, for instance, client certificates for the API server or server certificates can be generated from these, and everything should work properly. And as for the custom resources and the state of the extension controllers, how we're going to do that. And actually what we need to migrate for that. Here I've listed all of the extensions that we currently have and what their relation is to migration. basically the only ones that do custom extensions, which need to handle the migration of state individually, because we can't know what new extensions will be done. Then for the infrastructure extension, currently it only needs to take care of migrating the Terraform state. And the last one is the worker custom resource, for which we need to take care of machine controller manager related objects. So the goal here is that during migration, and of course after migration, the nodes of the shoot cluster do not get recreated, so that the user's workloads can continue working during migration. And as I said, this list depends on the currently installed extensions, and it can change in the future. So the way that we implement migration should account for that. So how will we actually do it? The first part of the proposal is to have a custom resource in the Garden cluster. What this custom resource does is it contains the state of the extensions that I mentioned above that we would need, and also the state of the secrets and any other data that Garner has generated. This custom resource is called shoot state, and it will reside in the project namespace where the shoot corresponding to the shoot state is also located. The shoot state resource has two sections. One is for Garner or Garner controller manager related things, whereas the other is for extensions. So the currently for the Garner related, one example for data that we would need to keep in the shoot state is the certificate authorities, the SSH key pair, and so on. And for this is how it would look for the extensions, where we would supply in kind the name of the extension resource for which we have to keep the state, and then of course the information about the state. So how will the migration workflow actually work? The migration, first some limitations for when migration can be started. We can only do it after a shoot has been successfully created. I will show why that is the case later. And we also need to make sure that the shoot's control plane can only be migrated if both the host seed and the new seed extensions controller support migrating their state. Otherwise, we can lose some information in the new control plane and not be able to completely recreate it. And as I said initially, the shoot's reconciliation flow should be reused for migration as much as possible. So the actual workflow, to start the migration, the field spec seed name in the shoot resource is changed to the name of the new seed. And then this automatically triggers reconciliation in the Garner controller manager. So what the GCM does is it will check the equality between this field and the status seed field. The status seed field is populated after a successful reconciliation, after a successful creation of a shoot has finished. This is why we needed that case above. And after the GCM detects that the two fields are different, it actually triggers now migration instead of reconciliation. So what the migration does then is checks if the new seed is ready. It tries to sync the shoot state. So what this means is that it will try to sync the shoot state from the seed cluster. Basically, it will list all the installed extensions, and try to get the state from the corresponding resources. If the seed is broken and the state cannot be synced, then the last successful sync is used to migrate the status. I will say how that is done a bit below. So then we stop the Shoots API server to make sure that we can create the snapshot of the etcd properly. We scale down the Shoots control plane in the host seed if we have access to the seed and we then resume normal reconciliation flow in the new seed. So during this normal reconciliation flow, the extension resources that Garner deploys contain the state from this should state resource, and they are also annotated with this new annotation operation equals restore. This instructs the extension controllers to reconstruct their state from the state field of the extension resource instead of reconciling the resource. So what is the biggest change, for instance, that we have to make for the should reconciliation flow? As I said, we need to keep in the state some of the certificate authorities and other secrets that the Garn controller manager generates. So the deploy secrets step has to be changed. It is split into two functions. The first one will it will still take a list of all required secrets. The first one will generate the certificate authorities and other secrets that are flagged that they have to be persisted in the should state and they cannot be regenerated. If they are regenerated, then we won't be able to start up the new control plane. And then the next step, it can still be called deploy secrets. What it actually does is now it takes these secrets that were generated by the previous step from the should state, and then either generates new one like client TLS certificates or server TLS certificates, and deploys all of both the generated secrets from deploy secrets and the generated secrets from the previous step in the shoulds control plane on the new seed. So for the Garner extensions, all extension controllers which will support state migration must have a new state field in their status. That's the idea for now. And support an annotation, which I mentioned above, which is called restore in their respective custom resources. So the state field, after successful reconciliation of an extension resource, is populated with the data that the extension controller requires to restore its state. This way, each extension controller knows what it actually requires, and it's independent of the Garner cluster. So as an example, here's a change that would be introduced in the infrastructure resource. As you can see, it needs the whole Terraform state, which can be saved in its status. So one problem with this, but we'll figure out if this is an actual problem later on, is if the state field is too big, then the API server, depending on configurations, might reject the status update. But in those cases, we can just move the state out of the status and add it in the spec or somewhere else. So to synchronize all of these states from the extension resources, we create a new should state synchronization controller, which can be part of the Garner controller manager. And what it does is before migration, it tries to sync the state of all extension custom resources from the shoulds namespace, from all should namespaces actually, to the Garden cluster and update the corresponding should states or the corresponding spec extensions fields in the should states. The sync also happens every X minutes depending on configuration, so as to also always have some states even if the seed is no longer reachable from the Garden cluster. And of course, we need to implement some type of leader election and control plane termination to avoid a split brain scenario where we have two control planes that operate on the same should infrastructure resources. So this section is still largely under discussion. Why is that? So the plan is to first implement the should state, modify the reconciliation flow and extensions accordingly. And many scenarios need to be considered for this leader election and control plane termination. which depend on the connection availability between the Garden cluster to the seed cluster and to the seeds API server, and the connection between the host seeds components to the Garden cluster, and of course the host seeds components to the host seeds API server. If the initial implementation that we'll do will only cover the case where everything is running, so everything is connected. This means that the Garden controller manager can take care of shutting down the control plane of the shoot in the host seed. Now, what are some things that have to be considered additionally? So extension controllers will not need leader election functionality because they anyway will only reconcile their extension resources if the reconcile operation is specified in the resource. This means that if we use some mechanism to shut down, for instance, the machine controller manager, then the provider extension or the worker controller will not scale it back up. Then for other controllers in the control plane, like machine controller manager, etcd backup, restore, kube API server, leader election has to be implemented. And here we anyway plan to introduce the Garnet soon. So the Garnet cluster is expected to be reachable from all seeds, at least in the scenario where the network is working between all components. And so the shoot's spec seed name can be used to determine which seed is the current leader of the shoot. This here, we would need it in the case that the Garnet, instead of the Garnet controller manager, can also take care of the scaling down the control plane after basically after all the shoot reconciliation flow has been moved into the Garnet. Okay, so horizontal pod autoscalers also need to be considered and removed so that if we scale down some deployments, for instance, of the MCM to 0, or not the MCM, but the Kube API server to 0, then if there are any configured horizontal pod autoscalers, that they wouldn't scale them back up. So some limitations regarding this topic: the controllers which run in the shoot's control plane should not be modified to account or to understand what leader election is. They should be agnostic to it, and they should also not know that functionality regarding control plane termination and control plane migration exists. We need to cover as many scenarios as possible for this. This means for the connection between the Gartner seed API server and the seed components. Here, it might not be possible to cover everything. I mean, there still might be some manual interaction necessary to actually shut down the control plane or somehow tell the control plane that it should no longer be running on the host seed. And of course, we should avoid complexity as much as possible. This means to avoid implementing new servers for leader election and adding a lot of new controllers to do that, and reuse as much as possible infrastructure resources or whatever we have currently available to do it. So some of the possible ideas to do leader election that we've discussed so far. As I said, if both the Garmin cluster and host seed cluster are ready, then the Garmin controller manager can directly scale down the shoot's control plane. Then in other cases, if the Garmin controller manager is available, the Garnet can use the seed spec name to scale down the control plane. And additionally, we can have some mutating webhook configurations that can create sidecar containers in the control plane controllers, in the pods of the control plane controllers. And the sidecar container will check whether the current seed is leader or not, again, by using this spec seed name. And if it is not, it can just shut down the networking on the pod to stop it from doing any changes on the infrastructure resource. on the infrastructure resources. And another idea that we also discussed recently is to use timestamp of successful reconciliation for leader election. What this means is that once a shoot, or at least the gist of it, is that once a shoot is successfully reconciled on the host seat, we assign the shoot to the seat by adding an assignment timestamp in the shoot state. Then this timestamp is propagated to the cluster resources and to a sidecar running in the etcd pod. The etcd pod can use this timestamp to check if it is still the leader by comparing it to any other timestamps if there exists, if such exist. So if the current timestamp of this etcd sidecar is newer than the timestamp that already exists, it means that this the current etcd needs to that actually the current control plane is the exists in the seat which is the current leader, and nothing must be done. But if there is so if there was an older timestamp, but if there is a newer timestamp, then this means that the current etcd sidecar is no longer the leader, or the seat in which it operates is no longer the leader. So the shoot control plane must be scaled down. If the timestamps are equal, then nothing happens. It just means that the same etcd is trying to write the timestamp. And then the other controllers can again use a sidecar as the previous example, and either get information from the Garner cluster whether the current seat is the leader, or the cluster resource which has been edited by this etcd sidecar whether they're the leader. And that is it for now.
Do we have this proposal uploaded already on GitHub somewhere? We can review it later.
No, I will do it right after the meeting. So the idea is, yeah, this is still under discussion. So I will upload it, and hopefully we can use the next week to add remarks, some new ideas as well, before we actually start implementing the control plane migration.
Yeah. Okay. Can you scroll down a little bit? So first thing, I don't know, you might have already considered it. Regarding extension controllers, I guess on old seed, we should have some mechanism with which we should allow deletion of resources without actual operation. So let's say we have infrastructure resource which is now migrated to new seed, right? But the infrastructure resource is still there on old resource, and obviously we want to do cleanup on old seed as well. So when we apply deletion timestamp over infra resource, it should simply remove the finalizer and remove the resource definition rather than actual do the deletion of infra resources, right? So
yeah. This we
see anywhere mentioned.
Yeah, thanks for reminding me. Actually, I forgot to add it. We did consider that we need to remove the finalizers.
Yeah. One more thing regarding the state field in extension. Can we introduce state as a sub-resource rather than the field in a status? Like scale sub-resource, we can have some, I don't know, so maybe state for now. Maybe.
So to be something
every
similar
extension resource. Okay, let me complete. So like we have scale sub-resource or status sub-resource, right? Similar way, we can have state sub-resource under which it will be like something, under which it will be raw data that will be dependent on controller will know how to interpret it. But let's introduce sub-resource called state, and this sub-resource will be generally used in KTS framework for migration stuff or something like that. We can have some.
You cannot have custom sub-resources on custom resource definitions. Currently, it's not possible. You cannot have custom sub-resources on custom resource definitions.
Okay, sorry. Yeah. One sec. Okay. Maybe version thing. I was just going, but make sure that I think on KTS community there is already proposal going on for that. Then I'm not sure it is integrated, merged or not, but we should keep aligned with that. So later on we can have at least state as a sub resource rather than and make use of it.
Yep, that's. I mean, if we can have it, it sounds nice. As I said, I'm worried if we can save all the information in the status.
Yeah, and third thing regarding the sidecar approach or regarding the leader election. So are we kind of bringing the dependency that seed garden cluster will be always reachable from seed cluster?
Yeah, we're
like
yes, we assume that.
Oh, okay. And what if it's not reachable? Then the leader election will fail, and both in old seed components in old seed and new seed will feel that they are leader. And okay.
So yeah,
I think we should try to avoid the dependency on garden cluster, or rather the way you thought, right? The spec.seed name. We know that shoot resource is copied as a part of cluster resource in seed cluster, but it may not be updated all the time. So yeah, and that's why I guess if you remember, I guess initially we had something similar on DNS based approach for leader election. Maybe we can discuss it later on.
Yeah. So just a quick note here. Basically, the second idea here. So this timestamp would we can also use an additional leader field in the cluster resource, which the controllers can check if it has been updated recently or not. And if it hasn't been updated, this means that leadership was lost, or at least hasn't been renewed. So then the seed cluster would lose leadership that way if it cannot contact to the government cluster. But with all of the approaches that we try, we also reach an endpoint where there's a question mark whether we should really scale down the control plane. So there's always a point where you don't know if migration was actually started or not. When this leader field hasn't been updated recently. But yeah, we can discuss this later in the PR.
Sure. Well, I might be some more confusion, but some more points, but maybe better discuss on PR because I have to also think on it. Thanks.
Yeah, hi. I have another question regarding the migration workflow. Can you scroll up a bit? Because you said when you, before the migration started, that you take a last snapshot or last, or the state is synced. And so for the extensions itself, you like say if it fails, you take the last successful sync. But for the etcd, what you do when this snapshot fails, you wait for the next snapshot to happen, or
just check whatever is available, because we don't know if the etcd will be able to create a new snapshot.
Yeah, so what is the approach there? Then you just like wait or stop the migration and wait for the next snapshot to happen, or retry until it's, or just use the last successful?
We haven't actually discussed that in length. Right now, I think the idea is to just use the last successful there as well.
Okay.
Just to be clear, am I audible? This is Amshu.
What?
Yes, you are audible.
Hello?
Hello, yes.
Yeah,
This
you
is
are
Amshu. Am I
audible,
audible?
Anshu.
Okay. Just for the point about HCD snapshot, before the migration is done, George is working on a PR for the integration of HCD Druid instead of directly deploying this HCD stateful set. It will, of course, deploy the stateful set. It has the additional functionality that he is also working on. Basically, when you scale down the replicas for Hibernation or for any other purpose, it will take one snapshot before actually scaling down the stateful set. So
So
the
then,
HCD implements the scale sub resource. So if that is decremented, then it would take a snapshot before actual stateful set is done. That might solve this problem.
Yep. So then we would just move, basically just combine the 6th and the 5th steps.
Yeah.
Okay.
Okay, so I have two maybe comments more than questions. So you said that we can't store. Yeah, we have this two choke points, right? We have the etcd choke point, which limits the object size to, I would, if I remember correctly, 1.5 megabytes. And we also have the watch serializer choke point, which if the infrastructure, if the resources increase greater than, I don't remember, it was, I think 1 megabyte, and maybe in 1.14 they increased it to 16. So if they are greater than or equal this number, then also watches will not work. And so infrastructure controllers also would fail to reconcile. I don't know what's the alternative solution, but we have to consider this two choke points on etcd and the watch serializers for the controllers. Have you? I don't know. So maybe I don't know if using another object to store the state
Well, we were either on. So we could use reference to a config map as well. So we'll just use the reference to the Terraform state config map.
It should be a secret, actually.
Or a secret.
Yeah, that would, I think, improve things because the resource itself wouldn't be greater, so watches would still work unless you also watch the config map. But I guess it's only at changes that we port in. So I guess this would be better than storing it in the infrastructure resource or in the extension resources.
And then, of course, this would also apply to the shoot state because it says it can have the same amount of information, I guess. And then this shoot state controller has to also update that. Yeah.
Yeah, and the other comment about the reachability of the garden to the seeds, basically, we try to follow the Kubernetes approach as much as we can. So in Kubernetes, if the kubelet can't reach the API server, it still can function. So pods are functioning except that watches. I don't know how to replace it, but I hope that we can still also maintain this model because we also embrace this mapping.
Yeah, this is something that we were doing yesterday, actually checking exactly how the kubelet behaves if it can't reach the API server anymore.
And it's simply it functions except that watches and all these things cease to work. But yeah, pods are communicating normally and everything. So sorry
to interrupt. Just the only thing that doesn't work, or at least stops working, is if you have a persistent volume. At least that's how AWS persistent volumes handle it. So if you have a persistent volume, the kube controller manager, after 6 minutes or some pre-configured timeout, will forcefully detach the persistent volume from a pod that is in the kubelet, which cannot connect to the API server, and then attach it to the new pod that it has created on another working node.
Yeah, but all the kubelets then won't be able to, so it won't be able to create new persistent volumes overall, or?
Not
because
sure
all the kubelets, if there is link failure between the API server and the kubelets overall, not just one. Yeah, what you said, I guess.
If all of them fails, then yeah, I guess it wouldn't be able to create the persistent bottom.
Maybe something was like they have now this topology field for the scheduler to also have high availability across different zones. Maybe we can also consider distributing the seed or the gardenlets of a seed onto different zones via and then we try to improve HA in some way. But yeah, I don't have a good idea at the moment also.
I think Martin was kind of going in that direction at one point while we were discussing this topic previously.
Yeah.
Okay, do we have additional questions? Doesn't seem to be the case. Thank you very much, Plamen, for presenting that and also for the discussion. Then we go to the next topic, the Gardner policy, versioning policy. Raphael, do you want to take over?
Yes. Okay, I need to.
The green button is for sharing.
Yeah, I know, but I got an OS X error message that.
Catalina update.
Yeah, someone is not allowed to. Wait a minute. Security. Security, privacy.
I think you need also to restart Zoom, right? Or
wait a minute.
so if you have any presentation, you can also send it to me. Then I can share.
Yeah, maybe that's the fastest thing now. I don't know how to give access now to this. Okay, I send it to you, Dominic. Just a minute. So send it. You got it?
Mm-hmm.
Okay. Okay. This is just an update of a new feature we plan to implement. It's not completely implemented. Some things are there, some things are missing, but it allows an operator of a gardener and a user to define policies when specific Kubernetes versions are deprecated or running out of maintenance. So what's the motivation? First of all, to make users of the gardener aware when a specific Kubernetes version runs out of maintenance, so they can plan ahead and make their updates. And this should be visible in the dashboard. It's not completely decided where we want to display it, but I talked to Lucas, who is the PO of the dashboard, how to display the specific states of Kubernetes versions and when they expire. And the other thing is that we also want, of course, give Garden operators a way to define their own Kubernetes version policy. This means how many Kubernetes versions are supported and how long are they supported, and when specific Kubernetes versions run out of maintenance. For that, we also have filed a proposal in the Garden repository. In the Gardener repository, under docs, it's number 5. It's gap number 5. You can also look up there for details and for updates. So next slide, Dominic, please.
Oh, sorry.
So how did we implement this, or how we plan to implement it? It's an animated slide, yes. Kubernetes versions, it will be possible to classify Kubernetes versions, and this will be maintained by the Garden operator, so the one who operates the Gardener, and this will be done in the cloud profile. So when the versions go through the maintenance life cycle, we define now the following states, and these states can be assigned to specific versions by an operator. So we will first have a preview state for quite new or for new Kubernetes minor versions. An operator usually then would tag this as preview until we have gained, or until he has gained sufficient experience. And as a result, when specific versions are tagged as preview, they will not be the default in the dashboard, so that not all new clusters for all users will use this new version. And after the first patch version, or it really depends on when the operator feels confident. So there's usually no clear rule, but then when the operator feels this minor version is already patched and now looks like stable, he can tag this version as supported, and then this version will be the default in the dashboard when he creates new users. And then time flies by, and we have the next state, which is deprecated. If an operator now thinks a specific version, a specific Kubernetes version should run out of maintenance, he flags this Kubernetes version as deprecated, and in that case, he should immediately, or in the same step, he should also add an expiration date to this specific Kubernetes version, and this will be of course in the future, and how long or how far it will be in the future is up to the policy. So it's up to the operator and their own policies, but the expiration date is planned that it will be displayed in the dashboard, that the end user really sees how long he has time since this cluster version runs from deprecated to the last state, which is expired. Expired will not be maintained by an operator in the cloud profile. It's more or less a logical state, so it will not be maintained by the operator. And a version is automatically in this expired state if the expiration date has lapsed. So what does this mean? It has several consequences. So first of all, it will not be possible to create new clusters with this version. And now comes the important part. The existing clusters will be forcefully updated in the next maintenance time window, even if the user has opted out of automatic Kubernetes versions updates. So what does this forceful update mean? This is also not implemented yet, but that's what we plan. So we forcefully want to update to the latest patch version. And if this patch version is also expired, then we would update to the latest patch version of the next minor version. And so on and so on. If this would also be expired, then it goes up the tree until he finds a version which is still supported. So this would be harmful, or could be harmful to the workload if we update to the next minor version. We are aware of that, but therefore it's up to the operator when he sets versions as deprecated and how long he gives the end users time to plan their upgrades. But at the end, when a cluster version or in a Kubernetes version is expired, it really will be forcefully updated, because usually a garden operator cannot have hundreds of Kubernetes minor versions and support them. So there must be a procedure how to update them or how to get rid of old versions. As said, this is an implementation. It's a gap in the Gardener repo, and it's planned, so this feature will come in the near future, I would say. And that's it.
Okay, thank you very much. Do we have any questions? Also not the case, then we have still a few minutes left. Do we have any topics which are not on the agenda yet? Okay, I think then we are done with the community meeting for this week. Thank you very much for attending, and see you next time.
Thank you. Have a nice day.